Okay, so now that we know what token types are, so each lexeme will be associated with a specific type. Okay, so the first thing we need to do is to make a list of the types that our language can recognize. So I created this new file called tokens.go, and in here I'll place all these categories of our lexemes. All right. So I could start off by saying const. Okay. I could say const. We need to be able to recognize the left parenthesis. Right. Of course, that'll be of type string, and that will look something like, right? So left paren. Okay. So whenever we encounter a left paren, okay, a left paren, then we will simply recognize that as this constant left paren. Okay. So this is one approach. However, the problem becomes whenever we're going through and recognizing all of our categories, then every time I meet a left paren, then I have to store this string in memory. Okay, and so if I have a lot of lexemes, then my memory will be filled up with a lot of strings. What we can do instead is, instead of using a string, we use a number, specifically an int. Okay, so I could say that whenever we encounter a left paren, that will be stored as a 0. Okay, maybe whenever we encounter a right paren, okay, that will be stored as a number in memory. And that will be recognized as a 1. Okay. All right. So this is one approach. Of course, instead of having to repeat const, we could just do it once. Okay. Parenthesis. Then of course we close that here. Okay. So this is another approach where we can use an int, and then we simply say each lexeme category, each category is given this distinct number. And so whenever we encounter these lexemes, these categories, we can just store them as a 0. Right? So for example, if I end up with that, then I know that will be stored as a 0 and a 1. Okay, which is much shorter than if we had strings where we had to say left, paren. Okay, and then we also had to store right paren. Okay, so this will take a lot more space in memory. Okay, so that's why we're using integers. Now I'm going to make this a bit more concise, and I'm going to use a type. So I'm going to say type, token type is the name of the type, and it represents an underlying integer. Okay. Okay. So now with that out of the way, I am going to use the built-in feature in Golang, which allows me to not have to repeat the numbers. Okay, so all I have to do is to start up by saying the first name, and then of course our type is token type, and then we're gonna say IOTA. Okay, and so of course this will start from 0. Okay, and then now I can just go ahead and say right paren. Okay, and then I can keep going. Right? I can keep going. So there are a bunch of different categories, and so let's break them up. We have, first of all, the single character tokens. Okay, so the left paren, the right paren, the left curly brace, okay. Brace. Okay. We have the right. Oops, let me not. Okay, we have the right brace, the curly brace. Okay, and we have a few others. So what I'm gonna do here is to pause the video, and I will write these out, and then when I come back, I will discuss them. Okay, I'll see you when I'm finished. Okay, so I finished all of the categories, the token types. So we have left paren, we have right, we have left brace, the right brace, the comma, the dot, the minus, the plus, the semicolon, the forward slash, the star. And then we have for those categories where it could have one or two characters. For example, I could use the bang, but then I could add another character to the bang, such as the equal. Then I have equal, and I have equal for comparison. I have greater than, equal, and of course I have less than equal. Then of course I have the literals, which is exactly as the name suggests, those things that should be taken as is. So for example, if I create a variable called name, well, that name is an identifier. If I create a string, right, Jane, that category is a string. And of course, if I create a number, then that category would be a number. And finally, we have the keywords. These are the words that are built in to our language. They should be recognized as well. And so we have the and, we have the class, which we will use to write classes. We have the familiar else and if. We have the Boolean false and true. And then of course, we have fun to declare a function. We have for, we have nil. We have print, we have return, super, this, var, to declare our variables, and of course while. And finally, we need to specify an EOF, an end of file, which tells us that this is the end of the source file and there are no more lexemes. There are no more tokens that are expected. So that's pretty much it in terms of the different types of tokens that we can see in our source file. They're all here. So again, the more token types you have in your language, then of course, the longer this file will be. All right. So we leave it here. With that out of the way, then the next thing we have to talk about and do is to actually create a token. Okay, so this is just the different types of tokens. But to embody a token, we have to specify that the type. Okay, we have to specify what the lexeme is. We have to specify if it has a literal value. We might want to specify where in the source file is located, right? The line number, the file name, so on and so forth. So this is the first step. We are specifying what the categories are. And because I have chosen to use the IOTA, which is simply integers, well, if I run my code, if I build it, okay, and then test it out, you'll see that I get a 2 here. Okay, and why did I get a 2 there? Well, because inside main.go, I simply did a simple print statement. Print left brace. Okay, and of course, left brace would be here, right? And so this, of course, would be 0. Right, so this, of course, we know is 0. And then, of course, we know this would follow along, which would be 1. And then, of course, so the left brace has to be 2, right? Because it's all numbers and it all starts from 0. Again, don't forget or remember, we said we will represent the token types as integers because they take up less space in memory and they're faster to compute with. All right, I hope that made sense. I'll see you in the next video where we create a new type which actually represents our token. I'll see you then.